So now let us see on how we can be able to find the vertical asymptotes and also the horizontal asymptotes, and for the rational functions. Now let's say we have a function given as y is equal let's say we have it as y is equal to, and let's say we have x squared and minus 5x, and let's say plus 6, and that divide by, let's say we have it as 2x squared and minus 4x, and let's say plus 3 in this case. So now how should we be able to have the vertical asymptotes and also the horizontal asymptote and for the function? So let's start with the horizontal asymptote. So as you can see, we have, this is the rational function with the numerator as well as the denominator. So we have to divide everything by the highest degree power of the denominator. So which means the highest degree power is given as 2x squared. So which means the highest degree power is given as x squared. So which means we have it as x squared divided by another x squared. That will be given as x squared here, and the minus 5x divided by x squared, and the plus 6 over x squared, and the divide by, we'll have 2 to the power x divided by x squared, and that should be minus 4x divided by x squared, and that should be plus 3 over x squared. So now let's think of simplifying this. So in this case we'll have this one as 1 and also 1, this is that, and also this is that, and also this is that. So now which means what will be remaining with, let me just have to transfer this first. So which means what will be remaining with will be given as y is equal to, now have 1 minus 5 over x, and the plus 6 over x squared, and which is divided by, we also have here 2, the minus 4 over x, and that should be 4 over x, and the plus 3 over x squared. So we'll have something like that. Then what will go up next? So in this case we'll assume that the x value is approaching the very largest number. So assuming that the x values assuming that the x value is approaching the very largest number, it means any number divided by the largest number, and that corresponds to half 0.00 something else, so which is the same as 0. So which means wherever there is over 0, it is the same as, and that should be 0. So in this case we'll have it as 1 minus 0 plus 0 over 2 minus 0 plus 0. So which means the horizontal asymptote, it is given as 1 over 2. So that's how we find the horizontal asymptote in that case. So now, how about the vertical asymptote? How about the vertical asymptote in this case? So how should you have the vertical asymptote of the function? Now, in this case, the vertical asymptote it is calculated upon having the denominator equal to 0. So what is the denominator? We'll have x squared and the minus 4x and a plus 3. So the vertical asymptotes are the solutions of the denominator. So is it possible to solve for the denominator? Because sometimes it is sometimes the function cannot have the vertical asymptotes. Hence, sometimes actually the denominator cannot give us the little solutions. So that happens as well. So let's see if that will work. So in this case, we'll have 2 times c. Actually, we'll have 2 times 3. That will be given us 6. So in this case, let's see if this one will be actually a factorizer. So in this case, you can see that that one cannot be factorized. So let's think of using the completing square method. Should be a quadratic formula, and see if we can be able to solve for x in that case. So now in this case, this is the value of a given us 2, and we have b, which is given us -4, and c, it is given us 3. So now the quadratic formula gives us x is equal to plus, should be minus b plus or minus the square root of b square minus 4ac in that case, and divide by 2a. So now let's think of substituting the given values, so which means we'll have negative, and this negative will have it as positive 4. So which means we'll have 4 plus or minus the square root of, in this case we have negative, actually a 4 to the power 2, which is given as 16. The minus, we have a 4 times what is the a, we have it as a 2, and what is the c, we have it as 3. So now you can see that inside you have the negative, and that will correspond to that the function does not have actually the vertical asymptote. So keep that in mind. In other words, there is no vertical asymptote, and for that case you should have to know. The next, let's see how we can be able to have, let's say, how we can be able to have the y-intercept as well as the x-intercept, if can be that. Now we have the function that is given us, that has been given us y is equal to, and that should be x squared and the minus 5x and that plus 6, and that divide by, let's say, 2x squared and the minus, and that should be 4x and that plus 3. Then what will be the actual y-intercept? Now the y-intercept will be calculated upon having x equal to 0. So which means we'll have y is equal to, now have 0 minus 0 plus 6 over 0 minus 0 plus 3, which is the same as 2. So this is the value of the y-intercept, where the graph is passing through the y-axis. How about the x-intercept? So now the x-intercept is calculated upon having y is equal to 0. So in this case we'll have it as 0 the over 1, which is equal to x squared minus 5x and the plus 6 over 2x squared. Now should be 2x squared and minus 4x and the plus 3. So in this case we'll have to cross multiply. We'll have it as x squared minus 5x plus 6, that will be equal to 0. Hence you'll be able to solve for the actual x-intercepts that one using the computer, actually using the factor method, it will work. And let's say we have this case, they also have it in the same way. See how we can be able to have in that of see how we can be able to have the horizontal asymptotes, vertical asymptote, as well as the intercepts. Let's say we have y is equal to, now we have x squared and minus x and the minus 6, and then divide by, let's say we have it as x squared and minus x, let's say minus 2 in this case. So now how should you be able to have the actually asymptotes? So let's start with the vertical asymptote. Now the vertical asymptotes are calculated upon having the denominator equal to 0. So which means we'll have x squared minus x minus 2, which is equal to 0. So we'll be able to factor this one out. So which means we'll have it as x squared and the minus, we have it as x. So it should be minus 2. X minus should be plus x minus 2. That will be equal to 0. So which means we'll have x and the x minus 2, and I'll have to factor out 1 there. I'll have x minus 2. That will be equal to 0. So now which means we'll have the equation in this form. So which means we'll have it as x minus 2 and the times x plus 1. That would be equal to 0. So in this case, the vertical horizontal should be the vertical asymptotes will be given as x is equal to 2 and also x is equal to negative 1. So these are the values of the vertical asymptotes you should know. And how about the horizontal asymptote? So now principle remains the same. What is the highest degree above the denominator? We have it as x squared. Hence we have it as x squared divided by the x squared and then minus x over x squared minus 6 over x squared, that which is over divided by x squared over x squared. So in this case we'll have it as that minus x over x squared, the minus 2 over x squared. So in this case this one will cancel, have that, and also that one also have it in that way. So what will go up next? Let me take it out first. So what we'll have is, we'll have it as 1 minus 1 over x, the minus 6 over x squared, that which is divided by 1 minus 1 over x, and then minus 2 over, should be minus 2 over x squared. So principle remains the same, assuming that the x values are approaching the very largest number. Actually it means we'll have it as 0 here, 0 here, 0 here, and also 0 here. So which means the horizontal asymptote, it is given as 1. So that's how you should have to get it up in that case. Then how about the y-intercepts in this case? So now the y-intercepts with the functions are calculated upon having, now should be upon having x being given as 0. That's how we find the y-intercept. So which means we'll have 0, 0, 0, 0, which means y will be given as actually a 3. So this is the value of the y-intercept you should know. And how about the x-intercepts? how should we have the X-intercept in this case? So the X-intercepts are calculated upon having y is equal to 0. So in this case we have 0 over 1, which is equal to x squared is equal to x minus 6 divided by x squared should be x squared and then minus x minus 2. So which means if you cross multiply, you'll be able to solve for actually X-intercepts in actually that case. So keep that in mind. And how about if we have this y is equal to, let's say, x squared minus, let's say, 2x minus should be about, let's say, we have it as 8 divided by, let's say, have x squared minus 36. So find all asymptotes and also the intercepts for this. What if you have y is equal to, let's say, x squared minus x, and should be, let's say, minus, and something about, let's say, 20, and divided by, let's say, have x squared should be x squared minus, let's say, 3x and minus 10. And then try to see how best you can go for this to have the y-intercepts, x, as well as the actually asymptotes, if it might work. So next we're going to see on how we can be able to sketch the graphs of actually these actually rational functions. So please don't forget to subscribe to my YouTube channel, that is GP Analytical School of Science, and for you to be updated for each and every content that is being uploaded. Thank you.